The lesson we just did on U substitution and this unit are the two most important lessons of this chapter, because most of the problems you'll see from this chapter on tests, quizzes, AP tests, come from these two sections, okay? So the fundamental theorem, fundamental theorem, anything that's fundamental is core, right? So the fundamental theorem of calculus says that, so why is it the fundamental theorem? Because it involves, conceptually it involves differentiation and integration combined. That's 90% of what we do in this class, right? Derivatives and integration, right? So that's why it's called the fundamental theorem, because it involves 90%. In one lesson, you do 90% of what we've done this semester, okay? So remember, anytime we find the integral, anytime we're doing any type of integration, antiderivative, why are we doing that? To find area under the curve. That's what it means, area under the curve, okay? So some of this involves stuff we've already done. Some of it is a little new, okay? So I give you an example here. So you're going to see capital F. Today and going on, you're going to see the capital F, not lowercase f. What does that mean? Capital F is the antiderivative of f. You know how, like last semester, we saw f of x, then f prime of x, then f double prime of x, and then so on and so forth, right? Well, since this semester we're going up the hill, right? Antiderivatives. Now what happens after this guy? It's the capital F, okay? So if I find derivative of capital F, I get the original. If I find derivative of f, I get f prime. If I find derivative of f prime, I get f double prime, right? If I go up, right, that's integrating. That's antiderivatives integrating, okay? So if you see capital F, it means it comes before, I know that's a bad term, but before the original, okay? So here we go. How do we do it? Well, here are the steps. I wrote the steps on the board too. First thing we got to do is find the antiderivative. How do we do that? Well, there's two ways we find antiderivatives. One way is the power rule. You did it on your quiz, okay? If we can do the power rule, do it. The second way is what we did last week. We ended the week with U substitution, right? That's also another tool in our toolbox. We can use that, okay? Whichever one is easiest to use, that's the one to do. That's the hard part. After that, you're just plugging in numbers. Plug in numbers, and then you're subtracting. Okay, so look at here. I know it's not blue and green on yours, but the example is here. That was the original problem. The integral of 3x squared from 1 to 5. So we need to find area under the curve from 1 to 5. So the first thing they did was found the antiderivative. What's the antiderivative of 3x squared? How do I find the antiderivative of 3x squared?
Plus 1 divided by the new x1.
When you do that, what do you get?
X cubed.
X cubed, right? That's step one. Step two is now we have to evaluate. So that's what that line means. It turns from a squiggly line to a line, because we don't use the squiggly anymore because we've already done the antiderivative. So why do we have the line? It says to evaluate now. So how do we evaluate? Evaluate just means plug in. Plug in the top bound first. Plug in the bottom bound next. Subtract. What did you get here? What did you get here? Subtract your answer. You get 124. Okay, that's the fundamental theorem. Okay, we don't need a plus c today because we have bounds. If you have bounds, you don't need a plus c. All right. Okay, so let's look at number one. Okay. So number one, first thing we need to do is find the antiderivative. I have to find the antiderivative. I have two weapons, two tools in my toolbox that I can use for antiderivatives. I have power rule U substitution or a combination of both. Don't use U substitution when you don't need to use U substitution, okay? Do I need to use U substitution for this function here?
I don't know.
Let's see, this guy right here. This is the function, right? So do I need to use U substitution for this guy here? No, because it's just one function joined together by a plus sign. There's negative 15x squared, positive 6x. I don't need to use U substitution. I can just use the power rule, which I've been using since before you guys took the quiz, right? So the first thing I'm going to do is find the antiderivative. Add a power, divide by the new power, right? So we get negative 15, add a power, divide by the new power, plus, do it again, 6x squared, divide by the new power. Don't need a plus c because we have bounds. So instead of a plus c, we're going to draw a line with the top bound and the bottom bound. I would suggest simplifying it first. 3 goes into negative 15, negative 5 times. 2 goes into 6 3 times, right? So simplify it a little bit. So you get negative 5x cubed plus 3x squared. And I need to evaluate it from 2 to 1. That's step 1. We just did step 1. Step 2, plug in the upper bound. The upper bound is positive 2. So I'm going to plug it into the antiderivative. I'm going to plug it into the antiderivative. So it's going to look like this. So negative 5 parentheses cubed plus 3 parentheses squared. What am I going to plug in? The upper bound. Okay. A little bit of mental math. So 2 cubed is 8 times negative 5 is negative 40. Plus 2 squared is 4 plus times 3 is 12. We add those together, we get negative 28. That's step 2. Step 3, do the same thing, but now with the lower bound. Now with the lower bound. So instead of plugging in 2, I'm going to plug in 1. And in between them, I'm going to put a minus sign, because that's step 4. Step 4 is subtract. But we don't subtract until we're done. Okay, so negative 5, 1 cubed plus 3, 1 squared, simplify. Let's see, 1 cubed is 1, times negative 5 is negative 5, plus 1 squared is 1, times 3 is 3. Add them together, we get negative 2. Last step, subtract. Well, if I'm subtracting a negative number, you're actually going to be adding, right? You're actually going to be adding when you subtract a negative number. So I get negative 26. So the area under the function, the highlighted function, from 1 to 2 is negative 26. So what does that tell you about the area? From what you know about area under the curve, what does that tell you about the area from 1 to 2? It's under the x-axis, yeah. It's under the, is all under the x-axis? No. But the majority, if not all of it is under. Yeah. Has to be, because that's why it's a negative number. Okay. Okay, so let's go to number 2 now. So I'll give you a hint. Not every time, but almost every time you have a fraction as a function, you're probably going to be using u substitution. Not all the time, but most of the time, you're given a function with some sort of fraction or rational expression. It's going to be a u substitution thing. Okay? If that's the case, this is what I do first. If I have a fraction and I have to do antiderivative, I'm going to rewrite the fraction so it's not a fraction. Okay? Just like you did last week. What do I mean by that? Well, I mean 4x, instead of division, I'm going to make it multiplication. So you can move it to the top or you can keep it as a fraction. I would probably move it to the top. Plus 3 cubed. Okay. Oh, negative 3, yep. Uh-huh. Negative 3, yep. Okay. U substitution, because we have a function times another function, and I don't have a product rule. I don't have a quotient rule, right? So what do we use instead of those for antiderivatives? U substitution, okay? So U sub. So the better you can get at finding U, the easier this will all be. If you can easily or quickly figure out which one's my U, the rest of it will be a lot easier. Okay, this whole process will be a lot easier. Okay, so which one is going to be my U here? Parentheses, yep, always. Couple things that give it away. It's got parentheses, right? Usually we start there. And if I find the derivative, which I'm going to do next, right? Is the derivative function going to be in there? What's the derivative of 2x squared plus 3? 6x, oops, this should be 3, right? Yep. 6x squared dx, right? I don't worry about the coefficient, I'm worried about the function, the variable part, right? X squared and x squared, they're going to cancel each other out. That's what I want. So I'm going to do that. Divide by 6x squared. 1 over 6x squared du equals dx. Just like you did last week, substitute. 4x squared times, instead of 2x cubed plus 3, I'm going to put that's where my u goes. And then instead of dx, I got 1 over 6x squared du. I only want u's. Remember, I don't want x's. They have to cancel out for this to work, and they do. X squared and x squared. And in fact, the 4 and the 2 will simplify to 2 times 3. Okay, so let me rewrite it. 1, negative 1, I have 2 times u to the negative 3 times 1 over 3 du. You can multiply the 2 times the 1/3 to make 2/3, right? I would suggest doing that and moving it to the front. I would suggest multiplying these two guys and then whatever you get, move it to the front. So 2/3, negative 1, positive 1, u to the negative 3 du. Okay. Still haven't finished step 1. Step 1 is I have to do the antiderivative. I haven't done that yet. I got to do that now. So add a power, divide by the new power. So we're going to get wait, is that 1/3 or 2/3? That's right. Oh, that's right. Okay. Okay, so here we go. So we get 2/3, right? Because 2/3 is in the front. Times u, add a power, If I add a power, what am I going to get? Negative 2. Divide by the new power, which is negative 2. Well, since I have a fraction there, I'm not going to divide by 2. I'm just going to multiply by its reciprocal, negative 1/2. From 1 to negative 1. Multiply. Negative 2, or sorry, 2/3 times negative 1/2 is going to be negative 1/3. Negative 1/3. Move u back in. U was 2x cubed plus 3. That's the antiderivative. Negative 1/3 times 2x cubed plus 3 quantity to the negative 2 power. Step 1 done.
Oh, no.
Step 2. Move them, plug them in for x. There's only one place to plug them in. So here we go. I always use brackets for each just to kind of keep them separate. So I get negative 1/3, parentheses, 2x cubed plus 3. Close brackets. I'm going to have the same exact thing, just plugging in a different number on the other side. Okay. I got a 1 and a negative 1. Plug in the top bound. Top bound is 1. Bottom bound is negative 1. Okay. Uh-huh.
You forgot the negative 2.
Oh, sorry, I forgot the power, yeah. Thank you. That's definitely important, yeah. Uh-huh. Yeah. Yeah, go for it. I forgot to close, yeah. So it'd be negative 2 power, right?
Yeah.
Negative 2, negative 2 power. Okay. Okay, so let's do one at a time. Let's do one at a time. Parentheses first. Again, this part right here, plugging in numbers, that is the part where I see students make the mistake, the number 2 and 3. The only calculus is step 1. Step 1 is the only calculus part. 2 and 3 are just plugging in and getting an answer. And then step 4 is just subtraction, right? But 2 to 4 is where I see mistakes made. That's the most often I see mistakes made. Students can do antiderivatives. They can use U substitution. But when they plug back in and you have some negative exponents or fraction exponents, kind of throws them for a loop, okay? But you guys know the rules of exponents, so it shouldn't be that big of a deal, okay? So here we go. 1 cubed is 1 times 2 is 2 plus 3 to the negative 2 power. Parentheses. Negative 1/3, 5 to the negative 2 power. What does negative 2 power mean? In basic English, what does negative 2 power mean to do? Square the denominator. Flip and square. Flip and square. So if I flip 5, what am I going to get? 1/5. Square that, what are you going to get? 1/25. So you get negative 1/75.
What an answer.
Okay, now let's go to the other side. Now both sides are the same, I just plugged in a different number. Negative 1/3. Negative 1 cubed is negative 1. So times 2 is going to be negative 2. Okay. negative a third. Let's see, 1 to the negative 2 power.
Correct me if I'm wrong, that's just one.
Mm-hmm. So you get negative 1/3, flip 1, and square it. What do you get? 1 times negative 1/3 is negative 1/3.
Oh my.
Common denominator is going to be 75, so multiply that times 75 and 75, or sorry, 25. Multiply the bottom times 25, the top times 25. It's just adding fractions. So you're going to get negative 1/75 minus negative,
25.
let's see, 25 and 25, negative 25/75. Minus a negative means plus, so you're going to get 24/75.
Guys, what's the percentage of that? All right, final answer, we gotta find a decimal. Oh dear, no.
All right.
I wonder what that actually is, the decimal. Almost. G, baby, no wonder. Well, at least it didn't.
Okay, let's go to the next one.
Yeah, maybe.
So this is the same thing we were doing last week, it's just with bounds.
Oh, darn.
Okay? All right, so here we go. It's got a exponent, or sorry, it's got a root and it's got a fraction, so I definitely want to rewrite it.
Four? That is a four, okay.
Yeah, it's a 4th power. So negative a 4th power, right?
Oh, man.
So it's vitally important that you are able to rewrite it because, again, that'll make your process a lot easier. Comfortable working with exponents that are not whole numbers, comfortable working with exponents that are negative, comfortable rewriting it, all things that have nothing to do with calculus. But the more you're able to do those things, the easier this process will be. Is it a tedious process? Yeah, it is, right? But tedious isn't bad when you're able to do it, right? Okay. So again, I'm going to use U substitution because I cannot distribute the fraction here because of this power. That power has to be a 1 for me to do that. So it has to be a U substitution problem. Okay, and in fact, 15/4, I can actually move to the front because that's just the coefficient. So you don't even have to worry about that till later. So 15/4, -1, sorry, to +2, and then 5x plus 6, -1/4 dx. U substitution. Well, there's only one thing left, it's just 5x plus 6 to the -1/4. So 5x plus 6 is going to be my u. Du is going to be 5 dx. So I get 1/5 du equals dx. U substitution. The 1/5 you can move to the front with the 15/4. Okay. I already did U substitution, so now I'm going to do antiderivative. Right, antiderivative is add a power. So I have 1/5 times 15/4. And then I add a power. multiplied by by the reciprocal of the new power. So the reciprocal would be 4/3. Evaluate it from 2 to -1.
What a bunch of fractions. All right.
Multiply the fractions. Let's see. That'll be 3, that'll be 1, that'll be 1, and that'll be 1. So it just equals 1, yeah.
Yeah.
Which is nice. No more fraction.
Why?
What are you doing, bro?
You didn't simplify the 1/5 to 15 over 4? I did that, got like 15 over 20. I'm like, oh, that's 3 over 4.
Okay.
Then I saw 4 over 3. I'm like, oh.
So I'm going to do two things right now. I'm going to move u back in, and I'm going to plug in the bounds at the same time. So u is 5x plus 6 to the 3/4 power. So I'm going to write that twice with the subtraction in the middle. So the first number I'm going to plug in is 2. The next number I'm going to plug in is -1. The better you can be at mental math for this part, the easier. If you're doing this in your head. Okay, so 5 times 2 is 10, right? Plus 6 is 16. What is 16 to the 3/4 power? It's easier than you think. You always see you. The other one is 5 times -1, which is -5, plus 6 is 1 to the 3/4 power. Okay. 3/4 power is not that bad. It's cubed, and then find the 4th root, or opposite. Which is easier to find? Is it, because you don't have a calculator, right? You don't have a calculator. Which is easier to do? Cube 16, 16 times 16 times 16, or to figure out what number multiplied 4 times makes 16?
Yeah, 4 times.
Yeah, what number times itself 4 times makes 16? 2. So this would be 2 cubed. What is 2 cubed? 8. 1 is the nicest base to have because it doesn't matter what power it is, it's always just going to be 1. Wait,
I gotta be all fancy. Who's that?
I looked at the next problem.
Yeah, you need to explain that.
Yes, it does.
No, it doesn't.
Yes, it
You better
does.
wrote your 7 all fancy.
ooh, I forgot to do that.
Okay.
Okay.
That was good, bro.
All right.
Oh, no. Not probably to get the circle out.
Okay. If I were to take off the bounds, you guys have done this before. You did it for homework. You are that's not anything new that you guys haven't seen. The new part is where you plug in the numbers afterwards, right? Mm-hmm. Okay. So don't even worry about the bounds right now. First thing you would do is rewrite it. So tangent of x to the 1/2 power times secant squared of x. I have two basic functions. I got the blue guy and I got the orange guy. Those are the two basic functions. What do we know about the relationship between tangent and secant?
Tangent's derivative is secant.
Mm-hmm. There's a derivative relationship there, right? Is the derivative of tangent secant squared? Or is the derivative of secant tangent? Which one is true? The derivative of tangent is secant squared, right? So I'm going to pick the blue as my u because it'll cancel out with the orange later. Secant squared. Divide, you get 1 over secant squared of x du, or sorry, d, yeah, equals dx. Okay, plug it back in. Tangent is where my u is going to be. Secant squared is going to stay because I didn't do anything with secant squared. Dx becomes 1 over secant squared du. You did it right. Everything that doesn't have an u should go away. All right. So secant squared divided by secant squared makes a 1. Okay. Antiderivative. Add a power, divide by the new power. So we get 3 over 2 divided by 3 over 2, which is just 2/3. And I got to evaluate it from pi over 4 to 0. Put u back in. Tangent is just, u is just tangent. Tangent of x to the 1, or 3/2 power, sorry. Evaluate it from pi over 4 to 0. Okay, now I'm ready to evaluate. Now I'm ready to plug in. So I have 2/3. So the way I do it is I rewrite it twice. I just leave out the x. And then I plug in the first number, simplify, plug in the second number, simplify, and then that's the way I do it. Okay, so tangent of x to the 3/2 power, 2/3 tangent of x to the 3/2 power. Pi over 4 and 0. So what is tangent of pi over 4? 1. Yeah, it's 1. I'm going to give you a hint. Most of the times, you see these powers, 3 over 4, or 3 over 2, 3 over 4, 4 over 3. Most of the times, they're going to give you something you can work with, right? Not something where it's going to be a crazy number where you can't, without a calculator, right? They're going to give you a lot of 1s. They're going to give you a lot of 0s. They're going to give you a lot of, like on the last one, we had 16 to the 2/3 power, 4/3 power, whatever. That broke down to a whole number, okay? So it looks a lot worse than it actually is. That guy is just 1. What's tangent of 0? 0. One to any power is just always going to be 1, so it's 2/3. 0 to any power is always going to be 0. 2/3. Okay. All right, we'll do, let's see, what's the next one? Yeah, we'll do one more, definitely, maybe 2 more, and then. So tomorrow, tomorrow we're just going to do some practice. I don't want to give you your assignment yet because we're just going to. If we have time, I'll give you some extra practice to kind of work on these. The steps aren't hard. Those are the steps we do for every problem. It's just getting used to them, right? Being used to those kind of things, okay? All right, so here we go. Rewrite. Again, if it's a fraction, move it, change it, whatever you need to do. When I say change it, I don't mean actually change it. I mean move some parts around mathematically correct so that it's easier, right? So if it's a fraction, most of the time I'll do this. -1 power.
For this one, could you have left it 2/7 times -x?
No, because it's a binomial down there. Yeah, okay. I can't distribute the 2 because it's a -1 power. If it was a +1 power, go for it. But it's a -1 power, so I can't do that. So what can I do first? Move the 2 out. Move the 2 out. And I'll give you another hint. Anytime you see -1 power in the back of your head, what should you also be thinking? Natural log, yeah. If you see a -1 power before you've done your antiderivative, you're most likely going to have a natural log somewhere in your answer, okay? Okay. So we have something to the -1 power. I can't do anything with a -1 power, so I'm just going to use U substitution. So the inside, 7 minus x dx. Oh, whoops, nope. The derivative is going to be -1 dx. Divide by -1, you get -1 du equals dx. Substitute. The -1, I would move to the front and multiply times 2 before you do antiderivative. So you don't have to worry about it, so it's not affecting anything. Antiderivative. Just like we thought, if I add a power to u and divide by that new power, it's going to give me something undefined. So the antiderivative of anything to the -1 power is just natural log, right? So natural log, not x, of u. And then I have to analyze or evaluate it from 6 to 5. Okay. So I have -2 times the natural log of something, and then -2 times the natural log of something. What is that something? 7 minus x, right? Okay. So now I'm going to plug in my so it's going to be 7 minus 6 first, right? And then it's going to be 7 minus 5. Seven minus 6 is 1, right? What's the natural log of 1? 0. So -2 times 0 is just 0. And then I get, what's the natural log of 2? A decimal, right? So if it's a value we don't know and we can't use a calculator, leave it as the natural log of 2.
Oh, okay.
Don't approximate it, because even if I had a calculator, it would just be approximation. It wouldn't be an actual value. An exact value, I should say.
Oh, okay. How fun.
So 0 minus a negative is going to be a positive. So it's going to be 2 times the natural log of 2.
Oh no. I see that E2
Let's save number 6 for tomorrow. I like number 6, but I'm not sure if we're going to have enough time to get to it. Let's do number 7, because number 7 is a problem you've had before.
Oh, absolutely.
And yeah, absolute value. So what is the rule? Anytime you're finding derivative, anytime you're finding antiderivative, anytime you're finding area under the curve for a absolute value, what's the rule? Always, always, always do what? Draw a picture.
Darn.
Don't try to use the antiderivative or the U substitution or power rule. Can you do it? Yes, but it's way more difficult than it needs to be, okay? When you're dealing with absolute values, draw a picture. It's so much easier if you do just draw a picture, okay? So this is kind of what you did on your quiz, okay? But I wanted to put this one on there just to show you that, hey, we still do the same thing, okay? Okay. So our bounds go from 0 to 5. 1, 2, 3, 4, 5. Then we're going to use the function to make points. And it's going to be a shape that you recognize. So when I plug in 0, here, I'm not doing antiderivatives, I'm not doing U substitution, I'm just plugging in numbers right now. So when I plug in 0 here, what am I going to get?
4.
Yeah, 4 minus 0 is, the absolute value of 4 minus 0 is 4, right?
Yep.
So it'll be positive 4, 2, make a dot. When I plug in 1, what do you get? 2. 4 minus 2, absolute value, 2. What's going to happen when I plug in 2? 0. One side is a straight line with a slope of negative 2. My dots aren't perfect, but oh well. Okay. What do you get when you plug in 3? Oops. You get negative 2, but then the absolute value is positive 2, right? So you get positive 2 again. Yep, just like you guys said. Take a wild guess. What do you think is going to happen when you plug in 4? 4. Take another wild guess. What do you think is going to happen when you plug in 5? Look at the pattern. 6.
I know what I want.
What is that?
I don't know.
Not pencil.
Well,
Dosage common. What a...
Area under the curve. So in other words, they want us to find area underneath the V.
3.
Those look like two shapes we have seen before. Triangles. So the bigger triangle is a what? 1, 2, 3 by 6. So that's 18 divided by 2, you get 9. The smaller one is 2 by 4 divided by 2, positive 4. Since they're both positive, add them together, you get 13.
Yeah.
So absolute values, draw a picture.
Absolutely.
Draw a picture. It'll be so much easier for you guys to do that way than to try using the rules. Can you use the rules? Yes, but don't even try.
Yeah.
Okay? Because it'll give you something that is going to give you headaches that you don't need. All right? So we'll finish the last few. I think there's 2 left, and then I'll give you some practice problems tomorrow, and then on Thursday I'll give you the assignment. So that gives you a few more days to finish the assignment over the weekend that I gave you on Friday. So I'm not stacking assignments.